Hey there, class. Mr. Pusky here. Hope you're having a good day so far. We're continuing with some new types of quadrilaterals. Today we're talking about trapezoids and kites. Say trapezoid. Say kite. All right, so we have no warm-up today, so let's get right into this here, okay? What's a trapezoid? See if you can draw a trapezoid without me describing what it is. All right, so a trapezoid is a quadrilateral with exactly one pair of parallel sides. One pair of parallel sides. I'm going to try to draw it up here. So we'll kind of go like that. So these would be parallel sides, and then the other sides are not going to be parallel. Yeah, that's a trapezoid. All right. The bases of a, I guess I should draw it down here too. I'm going to draw it down here. So the bases of a trapezoid are the parallel sides. The what? Parallel sides. That's going to be these right here. These are the bases, okay? And the base angles, all right? A trapezoid has two pairs of base angles, and each pair shares a base as a side. Okay, so let's draw another trapezoid here. So we have 1, 2, 3, and 4, okay? So 1 and 2, and 3 and 4. These are both pairs of base angles. Okay? All right, sounds good. The legs are going to be the two non-parallel sides. The two what? Non-parallel sides of a trapezoid. Cool. And an isosceles trapezoid is a trapezoid in which the legs are congruent. Or what? Congruent. So if I draw an isosceles trapezoid the best I can here, these are parallel, and these are congruent. Okay? A midsegment of a trapezoid is a segment that contains the midpoints. Contains the what? Midpoints of a trapezoid's legs. Okay, so that's all about trapezoids. And a kite is a quadrilateral that has two pairs of consecutive congruent sides. That also means adjacent, right? Side by side. But opposite sides are not congruent. Opposite sides are not congruent. And we're not going to do example 1 here. I'm going to try to draw a kite here. I'm really bad at these, so we'll kind of go like that and like that. So these are congruent side by side, but opposite sides are not congruent, okay? So yeah, that's kind of how it works. All right. Cool. So moving along here, we have some more theorems to learn about. If a trapezoid is isosceles, then each pair of base angles is congruent. So angle A is congruent to angle D, and angle B is congruent to angle C, okay? So they have to be the angles that are both touching the same parallel side, or the base, okay? Let's see here. If a trapezoid is a pair of congruent base angles, then it is an isosceles trapezoid. That's kind of the converse, right? So that's the converse, okay? And a trapezoid is isosceles if and only if its diagonals are congruent. Which other shape had congruent diagonals? It was a rectangle. Yeah, good job if you said that. So if and only if AC is congruent to BD. Nice. All right, so let's go ahead and do an example here. It says, use the properties of isosceles trapezoids. A shelf fitting into a cupboard in the corner of a kitchen is an isosceles trapezoid. Find measure of angle N, L, and M. Okay? So if this is an isosceles trapezoid, that means, and it's isosceles because these are congruent, that means the base angles are congruent, okay? So we know that this K right here is 50. So which angle is also going to be 50 degrees in here? Which one is sharing the same base over here? Hopefully you said it's angle N. So we know that angle N is going to be 50 degrees because it's a base angle. Okay? So angle N is 50 because it's a base angle. Now how do we find angle K and angle L, do you think? All right, well, this is kind of weird, but yeah, so we have parallel lines happening here, right? And we're looking for this angle right here, okay? What do we know about that 50 degrees and that angle L over there? Well, we know the measure of angle L, right? Those are consecutive angles between parallel lines, or consecutive interior angles, right? So yeah, so we're going to go ahead. What do they add up to? they add up to 180 degrees. So we can do 180 minus 50, and that's going to equal 130. All right, we're good. So that's 130 degrees. And now that we know that angle L is 130 degrees, what can we say about angle M? Well, that's going to be the other base angle, right? So, measure of angle M is also going to be 130 degrees. So it's a base angle. It's the same base angle as the angle L, okay? Oops. It's a base angle. It's 130 degrees. All right, sounds good. So once you find which angle is matches with the base angle, then you can do the 180 degrees with consecutive interior angles and go from there. Why don't you guys try the checkpoint, see how you do. All right, sounds good. So checkpoint 1, we have measure of angle C, A, and D is what we're looking for. We know measure of angle B is 135. Which angle is also going to be 135 on here? Well, this is the base, and the base that shares the side with 135 there for B is C, so we know measure of angle C is going to be 135 degrees. That's the base angle. If we want to find measure of angle A, well, what we need to do is we need to do 180 minus 135, which equals 45 degrees. Okay, so this is 45 degrees. And which one's also going to be 45 degrees? Well, measure of angle D is, because that's another base angle that matches with measure of angle A. All right, sounds good. There we go. Okay, sounds good. So we have what's called a mid-segment theorem, okay? So a mid-segment theorem for trapezoids. Basically, a mid-segment is like a line that connects the midpoints of, let me use a different color here. A mid-segment connects the midpoints of the legs of a the legs of a trapezoid. Okay, so that means these are going to be congruent, and these are going to be congruent, and also it's going to be parallel to the other sides here. Okay, and so we'll fill in these blanks here. So parallel to AB, parallel to DC. So those are going to be parallel, but there's a relationship between the bases and the mid segment. Okay, I'm going to label the top base X, the mid segment Y, and the other base Z. Okay. And here's what it is, okay? The mid-segment, MN in this case, is going to be 1/2 of AB plus CD, okay? That's what they want you to fill in the box here. But I'm going to give you, like, the actual formula here, and this formula is kind of important, okay? So the formula is Y, which is the mid-segment, equals 1/2 of X plus Z, or we could do Y equals X plus Z over 2. Okay, and this is the formula I want you to remember here. This is the easiest way to do this, okay? Those are the best ways to do this. These are basically the same thing, okay? I like the second one. I prefer this one the most, but either one is totally fine, okay? So the mid-segment is going to equal the two bases added together and divided by 2 or multiplied by 1/2. Okay? So let's do an example here. Let's do this. Example 3. We know MN is the mid-segment. We're looking for the mid-segment. So call this X, Y, and Z, right? We'll solve it two different ways so we get the hang of this here. So we know Y equals 1/2 of X plus Z, right? So Y we don't know. We're going to keep calling that Y equals 1/2 of what's X. It doesn't matter. You could call it X16. You could call it X9. I like to go top to bottom. So X is going to be 16, and Z is going to be 9, right? So we get Y equals 1/2 of 16 plus 9 is 25, and half of 25 is going to be, Y is going to equal 12.5, and that's going to be inches, okay? So that's one way to do it. That's the first way, or the second way up here. I like to just do it the other way, which is going to be to do Y equals X plus Z over 2. I think that's a little bit easier. So X plus Z would be 16 plus 9 over 2. And then you still get the same thing, which is 25 over 2, which equals 12.5. Okay? So either way is totally fine. Yeah, either way is totally fine. Okay? All right. Ooh, and we're actually going to do this one a little bit different. I'm going to show you the same problem a different way. Okay? I'm going to show you the same problem a different way. Why don't we say, let's see here. Okay. So we're going to do the same problem a different way. I'm going to make up a new trapezoid here. Let's see. I'm just trying to think of my notes, what we can do here. Okay, so we're going to do the same problem a different way. I'm going to change these numbers here. We're going to do a new trapezoid, okay? Here's a new trapezoid. We're going to say that we know the mid-segment we're going to say is 10. We're going to say this is 15. Actually, we're going to say it's 20. We're going to say this is 20. One of the bases is 20. And we're going to say we're looking for z, okay? Why don't you guys pause the video so you can figure out what we're trying to do here. But go ahead and see how you do. Okay, so this one's a little bit different, okay? Because sometimes on the test you're going to see, or with the stuff, you're going to be looking for the mid-segment, and sometimes you're going to be looking for one of the bases, okay? So for this one, we actually know we're still going to be y equals x plus z over 2, right? But in this case, we label our things. We got x, y, and z. We actually know y. Y in this case equals 10, right? So we have 10 equals x is 20 plus z over 2. Okay, now how do we solve this here? We're actually looking for z instead of the y. How do we solve this? We're going to multiply both sides by 2. Okay, so we get 20 equals 20 plus... This is actually not going to work out right. I just made this up off the top of my head here. But that's okay. You'd actually subtract... Let's change this to 30. Actually, it should be 30 up here. So say that x was actually 30, right? So you would subtract 30. That actually makes it worse. Oh, well. Basically, yeah, I made this up on the top of my head here because I saw it wasn't in the notes, but that's okay. So we get negative 10 equals z, which doesn't make sense, but you'll see from this next example, we'll do it both ways. But basically, if you're solving for a base or the mid-segment, it kind of varies on what you're doing here, okay? So yeah, okay, sounds good. All right, let's do another example here. Why don't you guys try the checkpoints, and then we'll do it both ways. So why don't you guys do it? We'll do it like we did for this one here first, the right-hand side one over here, but then we'll do it the other way too in a second. Go ahead. All right, let's label our things here. We have x, y, and z. We're looking for y in this case. So we're going to do y equals, it's x plus z over 2, so it's going to be 30 plus 12 over 2, right? And 30 plus 12 over 2 is going to be 42 over 2. So that equals what? 21. Very cool. All right, now I'm going to do the same problem, but say we don't know, let's say we don't know x. Say we don't know this is 30. Let's say that we know this is 21. Let's do the same problem over this way here. So we're going to do y equals x plus z over 2, but this time we know that y is 21. So 21 equals x plus z is 12 over 2. Okay, why don't you guys go ahead and solve that from here. All right, we're going to do times 2 to both sides. So we get 42 equals, we got x plus 12. These are going to cancel. X plus 12, subtract 12. We get 30 equals x. See, we got the same answer both ways. So yeah, so you can either look for the mid segment or you can look for a base using this, okay? I also don't know if you noticed this. This is kind of a pattern here, right? So the difference between the base and the mid-segment and the mid-segment to the other one is going to be the same, right? So go from 30 to 21, that's minus 9. And from 21 to 12, that's also minus 9, okay? So yeah, so that's kind of a way to do that, is basically the mid-segment is kind of an average of the two bases, right? So same thing here, we do minus, what was it? It's a 3.5. Yeah, minus 3.5 it looks like, and that would be the same thing there. So 16 plus 9 divided by 2 is the average of those two lengths there, okay? A little confusing, but make sure you ask questions if you have any more questions about that. Okay, kites. Last thing we're going to talk about are kites. Let's see here. Come on, you. Go away, please. Thank you. All right. So, a kite. A couple properties of kites here. And this is all in your quadrilateral flowchart, by the way. The diagonals are perpendicular. They're what? Perpendicular. So AC is perpendicular to BD. Oops. All right. And also, a kite has exactly one pair of opposite sides, angles that are congruent. So angle A is congruent to angle C, and angle B is not congruent. Okay, so here's the thing. The angles that are between the different types of congruent sides, right? These are congruent, but the ones that are the top and bottom of the kites are not. These are not going to be congruent, okay? These are not congruent. So there's only one pair of congruent angles, and they're going to be between the two different types of congruent sides, okay? So let's go ahead and try to apply what we know here by doing that, all right? So let's do this. Okay, so measurement angle T and the kite shown at the right. So we're looking for angle T. Which angle is angle T congruent to? Well, between the two congruent angles is going to be congruent to angle R. So now we can add these all up, right? How much do these add up to here? They add up to 360. So we can do x plus 70 plus x plus 88 equals 360, right? The interior angles of a quadrilateral add up to 360. Why don't you guys pause and solve from here if you can? All right, add like terms. X plus x is 2x. 70 plus 88 is 158 equals 360. Subtract 158. Oops. And we get 2x equals 202. Divide by 2. We get x equals 101 degrees. So angle T equals 101 degrees. 101 degrees. Okay. Why don't you guys try the second example like this if you would like to. Go ahead and do that. All right, same thing here. So we know that G, the kite at the right is shown, okay? So we're looking for these angles. These are both x. So we do x plus 85 plus x plus 75 equals 360, okay? All right, combine like terms, x plus x, 85 plus 75, we're gonna get 2x plus 160 equals 360. Subtract 160. 2x equals 200. Divide by 2. And x equals 100 degrees. All right, I'm gonna give you one more example that's not in your notes here, just really briefly here. We're gonna draw a random kite here, okay? So these are congruent. These are congruent. Okay, this is a really quick question. I want you to think about this here, okay? So let's say that this up here is 65 degrees, and that this is, let's say, 115 degrees, okay? And we want to find this angle over here. I want to find this angle right here, okay? Why don't you guys pause the video and think about what that angle might be. All right, do we need to solve, add these all up to 360 or no? We do not. Oops, I drew something up here. One second. So actually, this should be these actually should be congruent like this. Which angles are congruent here? X is going to equal 115. This is kind of a trick here, right? Because they're across from each other. They're between the two non-congruent angles. So this one you actually did not need to do any work. So a lot of these ones you're going to have to set them equal or do that and add them all up to 360. But if you know one of the angles that's between the two non-congruent sides there, you know the other angle is obviously just going to be the same thing. Okay? All right, that's all I have for you today. Thank you for watching. Have a great day, and we will talk soon.